Good morning, student. Let's start today's class. In today's class, we are going to study about voltage ampere characteristic of PA junction. Okay. Uh, from previous classes, we have already seen that the characteristic of the PN junction in biasing, okay, in forward bias and the reverse bias. And these characteristic, by using this characteristic, we can draw the VI characteristic of PN junction. That is voltage ampere characteristic of PN junction. We can draw a graph, and in this graph, the x-axis, the x-axis is represent voltage, and the y-axis is represent current. Okay, remember that. Okay, and this characteristic, VI characteristic, is drawn from the circuit here given. Okay, in the circuit there is a source, okay, and there is a PN junction, and there is a measuring device. Voltmeter here, voltmeter, and here ammeter. Okay, ammeter measure current and voltmeter measure voltage. Okay, now, and we can divide this process in three categories. One is when there is no external voltage applied, and next one is when forward bias, and next one is when reverse bias. Okay, first discuss about when there is no voltage applied. Okay, when there is no voltage applied, you know, the potential barrier of PN junction is there. Okay, due to this potential barrier, okay, there is no charge flow between that PN junction, so that there is no current flow in the circuit. Okay, so the current flow is 0, and this is represented here point O. This point O is represent no external voltage, okay, applied. Okay, so in no external voltage, there is no voltage and no current. Okay, next one is forward biasing. Okay, next one is forward biasing. In you have already known about the what is forward biasing. In forward biasing, the p type terminal of PN junction is connected to positive end of the source, and the n type end of PN junction is connected to negative end of the source. Okay, in and also in forward bias, the depletion, the potential barrier is decreases gradually and eliminated at a stage, and in the stage the current flow in the circuit is happened due to the transfer of or crossing of charge through the potential barrier. Okay, and there is a flow of current in the circuit. Okay, after destroying of potential barrier. Okay, and this is represented by here O to A, represented by O to A when forward bias. Okay, this is forward bias side, and this is reverse bias side. Okay, in forward bias from what O to A, there is a slow increasing curve. Okay, slow increasing, because when in this duration the depletion region gradually decreased. Okay, the depletion region gradually decreased, so the voltage, the applying voltage is used for decreasation of depletion width. Okay, so it is gradually increased, the current is gradually increased. Okay, but in from A point, but from point A, this point is called knee voltage or knee point. Okay, and this point A, the current increases rapidly. Okay, there is like a linear. Okay, there is a straight line, the current increases rapidly. Okay, that means from point that means at point A represent there the point at which the potential barrier fully destroyed. Okay, there is no potential barrier in the PN junction in forward bias. Okay, so the point so the knee voltage is that the knee voltage is that the forward voltage the maximum forward voltage or the maximum forward voltage for destroying the potential barrier of PN junction, fully destroying the potential barrier of PN junction. That means ଯେତିକି ଆମକୁ ଫରୱାର୍ଡ଼ ଭୋଲ୍ଟେଜ୍ ଦରକାର ଆମର PN ଜଙ୍କସନ୍ ପୋଟେନ୍ସିଆଲ୍ ବ୍ୟାରିୟରକୁ ପୁରା ଭାଙ୍ଗିବା ପାଇଁ ଯେତିକି ଭୋଲ୍ଟେଜ୍ ଦରକାର ସେଇ ଭୋଲ୍ଟେଜ୍ଟାକୁ କୁହନ୍ତି ଆମର ନି ଭୋଲ୍ଟେଜ୍. ଓକେ, एंड से पॉइंटा कहती जो पॉइंट रे सेटा पूरा भांगी जाए से पॉइंटा कहती नी पॉइंट. ओके, नेक्स्ट इन रिवर्स in reverse bias, you know the p side of the PN junction is connected to the negative point of the terminal of the source, and n type of the n side of the PN junction is connected to the positive end of the source. Okay, and in reverse bias the potential barrier width is increased gradually. Okay, here the potential barrier does not decreased, it increased gradually. Due to this increase of potential barrier, there is practically there is no current flow inside the circuit, but in practice or in practical there is a little or small current, a very small current or of order of microampere flows in the circuit with reverse bias as shown in reverse characteristic. Okay, this is called reverse saturation current. Okay, and this is due to the minority carrier. Okay, in reverse bias the majority carrier are repelled by the potential barrier to cross the potential barrier, but the minority carrier is attracted by the potential barrier, and that's why the minority carrier cross the potential the junction PN junction, and there is a small current flow in the circuit. This current flow is called reverse saturation current, and this current is due to the minority carrier. Okay, sorry, and these understand the on these undesirable free electron in p type and hole in n type are called minority carrier. In p type semiconductor the minority carrier is free electron, and the n type semiconductor the minority carrier is positively charged hole carrier holes. Okay, and due to this minority carrier the reverse saturation current or a small amount of current is flow in the circuit. Okay, this what this is small what this small currents or small current represented from O to this point. Okay, when the current slowly increased. Okay, and due to the minority carrier. Okay, there is a little load, and in from point breakdown voltage in is that in breakdown voltage is the reverse voltage or reverse bias voltage at which the potential barrier is destroyed. That means by continuing flow of this little bit of minority carrier current, by continuing flow of that the potential barrier is destroyed completely. Okay, is destroyed completely. From that point or that reverse voltage at which the potential barrier break completely is called breakdown voltage. Okay, here the forward voltage at which forward voltage the potential barrier break, that is called knee voltage, but in reverse bias the amount of reverse voltage at which the potential barrier destroyed, that is called breakdown voltage, and after that the current is flows rapidly. Okay, the current is flow rapidly, that's why there is slow and rapid increase of the graph. Okay, then 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 I told you that what is breakdown voltage and what is knee voltage. Breakdown voltage is, it is the minimum reverse voltage at which it is the minimum reverse voltage at which PN junction break down with sudden rise in reverse current. Okay, breakdown voltage is, this is the minimum reverse voltage at which PN junction break down with sudden rise of reverse current. That means I already told you that by continue flow of that little bit of or the little amount of reverse current. Okay, little amount of reverse current, and at one stage the potential barrier breaks and sudden rise of that reverse current, and that voltage and that point is called breakdown voltage. Okay, or breakdown point voltage point. And in knee voltage, it is the forward voltage at which the current through the junction start to increase rapidly. Okay, here you see the for silicon knee voltage is 0.7. After 0.7 voltage, or after giving 0.7 voltage, the current or the potential barrier is destroyed of the silicon PN junction. Okay, and the current flow increase rapidly. But in germanium, this potential barrier is point 0.3 volt. Okay, after 0.3 volt, after giving 0.3 volt, this current is increased rapidly, the potential barrier is destroyed. Okay, okay, thank you.